everybody. Let's get started. Good afternoon, folks. Welcome to the North Carolina Museum of Natural Sciences, and welcome into the SCCU Daily Planet Theater. You have made it for Dino Dig Live! Thanks for cheering. I appreciate it. This is a special and exciting program that we offer here at the Museum of Natural Sciences. I'm your host. My name is Chris. I work in education here at the museum, and I get the pleasure and privilege of, introducing some of the cool experts that work here at the museum and are doing incredible, awesome, fascinating work out there in science and nature. And for Dino Dig Live, this particular program, we are connecting in real time on the internet via video. Isn't that cool? That's pretty cool, right? To our paleontology team, who are right now in the middle of somewhere in Montana. And as you can see on the screen behind me, they are right now digging up fossils. Every summer, the paleontologists here at the museum head out and go look for fossils all around the world. And today, right now, I want to introduce you to a member of that team who's going to give us an update on their progress and talk a little bit about what it's like to be a paleontologist in the field. Everybody say hi and hello to Eric Lund. Hi, Eric. So, Eric, give us an update. How are things in somewhere Montana? All right, well, Eric, you can hear me. Hey, Eric, I think you're muted.
Can you hear me now?
I can hear you, but I can't see you.
Okay.
There
How
you
about
are.
now?
We'll try it
And
again.
can you hear
Everybody say
me?
hi, Eric.
All right. Is that better? Can you all hear me now?
Everybody can hear? Everybody can hear? Thumbs up. You can hear? Yeah, we're good. We're great.
All
You look
right.
great, Eric, too. I like that hat.
All right. Thank you. Yeah, it's very peachy. um, but yeah, Chris, we are out here in eastern Montana in rocks that represent the last stage, the last time that non-avian dinosaurs were alive on this planet. So we're working in rocks that are about 66 million years old. And things are going great. We are, as you can see behind me, we have this really large fossil jacket that we've been working on. That fossil jacket contains one of the world's best Sabellites fossils. And Sabellites is a palm frond. So a Cretaceous palm frond that we have, it's complete from the tips of the leaves all the way down to where it broke off from the trunk of that tree. And so that's really, really exciting. And we've found a few other fossils from this quarry, few pieces of Triceratops, and then around the area, we've got a few pieces of crocodile and turtle and stuff. But things are going really well. The biting flies have gone away. We lost one day to rain, but otherwise, it's a beautiful day here. It's probably in the low 70s. It's sunshiny, so we don't have any rain anymore, and it's really great.
Glad to hear things are going well for you out there. Tell me a little bit about what the crew is working on right now. We can see everybody diligently digging and swinging tools. Tell us a little bit about what's going on exactly.
Yeah, that's right. So we're getting ready today to flip this big fossil jacket over. And so right now it's sitting up on three pedestals of rock. And so we're working to reduce those pedestals down until the block can be wobbly and we can flip the whole thing over. And right next to me, right behind me here in the blue, that's Kyla. And Kyla is working with a pickaxe and she's picking down the floor so that we can make a nice flat and relatively soft spot for this jacket to flip over into.
Wow, very cool. How, like, I can kind of see some of the tools and people next to the big white plaster fossil jacket. How big and how heavy is that piece of rock?
Yeah, so as it sits right now, still connected to the earth, it's probably around 5,000 to 4,000 pounds. When we get done with it, I'm hoping to reduce that weight down to about 2,500, 3,000 pounds. So it's pretty heavy. It's pretty heavy. And once we're going to have to break it off of those pedestals and flip it over. And we're going to, later today, we're going to be rigging it up with a bunch of rigging equipment, straps, and things, and using a manual winch to help us pull that thing off the pedestal and flip it over into a helicopter net. So there's no way that the eight of us here can throw this on our backs and carry it up out of the field. And so we're going to have this thing fly. And so we're going to flip it right into a helicopter net. And then later in the year, in September, we're going to come back with a helicopter and make this thing fly out to a trailer and then drive it back to North Carolina and to the museum.
That's pretty cool. A flying palm frond in the middle of Montana. So tell us a little bit about, again, because we got cut off there at the beginning, where you're at, why you're there.
Yep. So we're here in the world famous Hell Creek Formation in eastern Montana. So Hell Creek Formation represents the time in Earth's history from 69 to 66 million years ago. It represents the time just right at the end of when dinosaurs, non-avian dinosaurs like T-Rex and Triceratops, were on this Earth. And so we've been coming out here every year since 2016 to look for fossils and of all different kinds of things, crocs, birds, fish, dinosaurs, to try to reconstruct the ecosystem that of this area 66 billion years ago. And so this quarry right behind me was found in 2021. And when it was first found, there was a small crocodile right on the surface that we could see. And so we started to collect that. And in doing that, we started finding bones of a juvenile Triceratops. And so this site went from a crocodile site to a juvenile Triceratops site, and now it's a plant site. And so that's sort of the evolution of this quarry.
So tell us all a little bit about how you found these fossils to begin with, because you said the crocodile was at the surface, but then you started digging and just uncovering more. Did you expect to find more underneath? How did you find these?
Yep. So uh, technologies like ground penetrating radar and things like that don't work for us. So we can't use technologies really to look into the rock to see fossils. So we actually have to see fossil on the surface of the ground. And once we find fossils on the surface of the ground, we try to chase it uphill to find the layer where those bones are coming from, and then dig in. And once we start digging in, we hope to find more. Oftentimes, we just got the pieces on the surface, everything's gone. But occasionally, like this quarry, we get lucky. And so the crocodile was being exposed by modern weathering. So we saw the bones of that animal right on the surface. So we started to dig around it. Like you see, we've dug around this big palm frond here. So we dig around it. We took it out in a small, much smaller fossil jacket. But in doing that, digging around that crocodile, that's when we started finding much larger bones. And we soon realized that those larger bones were from a dinosaur and specifically from a very young individual of Triceratops. And we've brought those bones back to the museum and we've done some work on those. And it seems like the juvenile Triceratops we found is perhaps right around 3 or 4 years old. So just a little guy.
Okay, so a baby, a juvenile Triceratops. Is that? I can't say I've heard of baby Triceratops being something you find a lot in
Yeah,
paleontology.
there's not many of them. There's not many of them, though. We've got only a handful of specimens, um, which is so. It was really exciting when we started finding these little bones belonging to one of the most well-known dinosaurs.
What is your favorite dinosaur or type of dinosaur, Eric?
So my favorite type of dinosaur is the horned dinosaurs like Triceratops, and my specific favorite is an animal called Nasutoceratops. So Nasutoceratops is in the same group. It's related to Triceratops, but it predates Triceratops by about 10 million years. And the reason it's my favorite is I found the very first one. So the holotype specimen, the specimen that we use to name that animal. And so myself, along with colleagues, named that animal in 2013. So that's my favorite one.
So the one that you found and helped name, that's your favorite.
That's
But
right.
then It must have been pretty exciting to find a young Triceratops fossil too. Then, since these are your
Absolutely,
like specialty.
absolutely. Yep, absolutely. Any horned dinosaur pieces that we find, I really I really like finding those.
Love it. I'm so happy for you. So, hey, if you're here with me in the Daily Planet Theater at the museum, or if you're watching online, you all can ask questions that you have about dinosaurs, paleontology, fossils, ancient life, what it's like to work in the field, anything at all. All you got to do is wave at me, let you know you've got a question. And then you can actually, if you want, come up here on stage, use the microphone, talk directly to Eric in the field in Montana, or you can just tell me what your question is from where you're sitting, whether on the first, second, or third floors or online, and then I can repeat your question into the program. And we can see what you want to know, and we can learn more about what Eric knows. So, Eric, we can see the work that's going on. We've seen where you've dug in around. Tell us a little bit about. You said this was found in 2021. Has it taken like fully 3-4 years of work in order to get this thing ready to fly?
So not the palm frond. So the palm frond was found last year, but this quarry itself was found in 2021. So we've been working at this spot, coming back to this same spot since 2021. But the palm frond we found last year, and we mostly got it. We got it protected because it was found right at the end of our field season. So we just got it. We sort of dug around it, got it exposed, put a protective cap on it, put a tarp over it, and then buried it back in so it would be protected over the winter. And then when we came back out here at the end of July, we had to dig all that back out. And then since the end of July, we've been working to excavate more around it, get more layers of plaster and burlap. That's what the white stuff is on this fossil block is layers of plaster and burlap. We've plastered in big sticks into this jacket because it's a sort of a long skinny thing. So the sticks will help keep it from flexing. Um, and keep it safe when we flip it over to the other side.
How often do you find fossils when you go looking for them in places like the Hell Creek in Montana?
So the Hell Creek is a pretty unique area. It's really hard to not find fossils here. You pretty much, especially Triceratops. So the area that we're in, it was for whatever reason was just full of Triceratops. So it's hard to not walk around and trip over a piece of Triceratops. Um, the other fossils like T-Rex, smaller meat-eating dinosaurs, the duck-billed dinosaurs like Edmontosaurus, pieces of those are fewer and farther in between. But out here, you can walk in any direction and look down at your feet and find a piece of turtle or crocodile or a piece of Triceratops.
Do you do you keep every piece that you find? Does everything come back to the museum? How do you decide what to dig up and what to investigate?
Yep. So we don't keep every piece. So things that will are scientifically important, things that we haven't seen. So like those small meat-eating dinosaurs, um, if it's a really nice piece, then we'll collect that. If it's already broken up and weathered, we'll just leave it where it lays. Some of the other cool things that we find here are coprolites, so fossil poop. And if it's a really nice poop, then we'll collect that and bring it back. But otherwise, once things have eroded out of the hill, weathered out of the hill and start to break up, if we can't find all the pieces, then we kind of will just leave it where it lays. But if we can add to the scientific knowledge about any of the animals around here or any of the plants that were around here, then we'll collect that stuff and bring it back to our museum so that ourselves or other researchers can come to our museum and study these things and then publish papers on all this stuff.
I love that you're like, well, we'll sort of look over the shell fragments of turtle, and maybe we won't pick up every crocodile tooth. But you know what? When we find a good poop,
That's right.
we're going to bring it back.
Can't pass up a good poop, Chris.
All right, let's do some audience questions. Go for it. Oh, okay. You're going to like this question, I think, Eric. So, based on the types of animals and the fossils that you're finding, palm fronds and all of that, what does that tell you about what this place was like millions of years ago?
That's a great question. Yeah. So based off of all the animals, the rocks that we see, the plant fossils that we find, this area was much different than it is today. So you can see behind me, it looks very desert-like and it's very dry most of the time. But when these animals were alive, this was a very verdant and green and lush environment, and with big, huge rivers. So we had big mountains being built to the west of us, and huge rivers pouring off those mountains into a seaway that was to the east of us. So during this time, during the Cretaceous, North America was divided into two land masses. The western side here was called Laramidia. The eastern landmass, where you all are there in Raleigh, was called Appalachia. And so we had this giant seaway running up and down, splitting North America into two, and these big rivers flowing off into that big body of water. And so these dinosaurs were just roaming up and down that piece of land between the ocean, the mountains, along all these big river systems.
Wow, that's incredible to think about. A place that it looks so dry, that's like just all pretty much one shade of brown all around you. It looks
That's
like
right.
just used to be green and verdant, and that's wild. All right,
That's
another
right.
question.
Oceanfront property.
Oceanfront property. Eric, in all the places you've been, where have you found the most fossils?
Oh, that's a good question. So I've been lucky enough to be able to work all around the world. I've done work in Madagascar. I've done work in Mexico. Um, and so probably the most fossils. I mean, here in the Hell Creek, we've found quite a bit. But the Comparowitz Formation in southern Utah is another place where I have personally found lots and lots of fossils. But Madagascar was another place. You get these huge sort of multi-taxa bone beds of dinosaurs and birds. Um, and so there was a lot of fossils there as well.
Cool stuff, Eric. All right, so look at Eric over there. Tell us your name, and then you can ask your question.
My name is Irina. Um, so my question is from everywhere you've been, like everywhere that you look, like where do you know where to look
Great
for
question.
finding the
So
fossils?
yeah, so that's a really good question. So we don't just randomly pick an area to go look at the rocks. So one of the things that we do is we have to stand on the shoulders of geologists who've come before us that tell us that these rocks are of the right age. So we need an area where the rocks are the right age, and then we need rocks of the right type. And so our group at the museum, we're really interested in dinosaurs and other animals that lived on land. So we got to have terrestrial rocks. So we don't want the rocks that were deposited in the ocean, marine rocks. And so we got to have the right age rocks, the right type of rocks. And then we look at a geologic map and we figure out where the right type and right age of rock is exposed on the surface. And then we'll go to those areas. And if there's not a lot of other groups working in there, in that spot, then we can go and apply for permits to go look for fossils. But yeah, that's how we do it. So we look at a geologic map, figure out the right where these rocks are, and then try to see if we can get in there and go to work.
You.
Thank you.
Great question. Let's do another one. You want to come up? Yeah, feel free. Come on up. Look at, tell us your name, and then look at that screen to talk to Eric back there.
What? My name is Daniel, and what was the like most dangerous fossil you found?
The most dangerous. Do you mean in terms of like what do you mean by most dangerous?
Like millions of years ago, how dangerous it was, like millions of years ago, like dinosaurs.
Uh,
Like,
the,
what was
the,
the
the dinosaur.
yeah, like which ones you found and were like really dangerous?
So I think if the question you're asking is which so T-Rex, we do find T-Rex out here, and T-Rex was one of the most formidable dinosaurs to ever live, and so you wouldn't want to be hanging out with a T-Rex because it would probably eat you. So that would probably be one of the most dangerous dinosaurs around. But Triceratops as well, with those three big horns on its head, um, probably could do some damage as well.
Yeah, I guess the king of all dinosaurs, Tyrannosaurus Rex, was a pretty dangerous one to think about coming across.
That's right.
But you know what? That actually also brings up another question. I have a feeling that there's modern day wildlife hanging out with you around your dig sites and around your camps. Have you had any fun interactions with, the locals there?
Yeah, so we've there's a herd of elk that live in these hills behind us, and so we've been able to see that herd of about 50 elk running around here. We've seen a few white-tailed deer. We've seen signs of mountain lions, footprints in the mud, but we haven't seen the big cats themselves. They've probably seen us, but we haven't seen them. As far as snakes, we haven't seen any snakes this year. Um, but we do know that there are rattlers here, rattlesnakes, and I have seen them. I just haven't seen any this year. We also get really cute little horny toads that are, those aren't dangerous. Those are very gentle and just cute to pick up and hold. And, but yeah, as far as the kind of spooky animals, the mountain lions, I think, are the ones. Um, and then yesterday we were visited by the BLM wildlife biologist, and he told us that bears have also been seen in this area, but we haven't seen any bears either.
Wow, that's crazy stuff. All right, yeah, come on up. Tell us your name, and then you can chat with Eric.
My name's Kirsten, and my question was, how do you go about getting a job in paleontology?
Yeah, it's a great question. So paleontology is very interdisciplinary. So when you go to university, get your undergrad stuff out of the way, and then when you got to go to grad school, in grad school you can sort of focus on the thing that you like to do. Um, but use your undergrad to sort of figure out what it is, the subjects that you like the best, be it biology, physics, chemistry, computer science. Doesn't matter because paleontology draws upon all of those disciplines. Um, and then for me specifically, I started hanging out at my local museum, and I started as a volunteer first, which is which is a really good way to get your foot in the door and start volunteering in the fossil prep lab, or even come out here on digs with that group is another way. But yeah, so you gotta go to grad school. You can either a master's or go all the way to a PhD. But there's many ways that you can sort of find your way into paleontology.
Cool stuff. There's a question that came in online for you, Eric. Wonder what you think about it. How can climate change in the prehistoric past help us understand our current climate crisis?
Yeah, so that's a great question. So paleontology and being out here in rocks that are 69, 66 million years old, and seeing the flora and fauna change gives us an idea, gives us a deep time perspective on those questions of current climate change and the problems that we're having. And we can sort of, look back at what the environment was like and the changes that happened then. And we can sort of model current climate uh, changes and draw upon the things that Earth has gone through in the past to try to help figure out um, what's going on currently. And we've got computers these days, so we can sort of model, put all this data in, and let things give us ideas, models to project forward what might happen, and then we can try to come up with scenarios and ways to mitigate some of these things. So Yeah, so deep time perspective on stuff helps us kind of answer those questions.
Cool stuff. All right, yeah, come on up. You want to chat with Eric? Here you go.
How do you know when the dinosaurs died?
So specifically in this formation are all dinosaurs at 66 million years ago. Well,
Let's do
so
both. Yeah, how do you
yeah.
what about the animals that you're finding there and about
Yeah,
how
so
they died?
occasionally we can look at at the bones here at a particular quarry, and we can see bite marks on them, wounds, damage. Um, and so that maybe can give us an idea of how the animal died. Um, or we know that 66 million years ago on this planet, there was a giant bolide impact. And I don't know if you can see it in the rocks behind me, but there is a layer, there's a very dark black layer. That is the KPG boundary. So below that coal lens, we're in the Cretaceous, and above that coal lens, we transition into the Paleogene. So that coal seam represents the time when dinosaurs, went extinct 66 million years ago. And so it was, that bolide impact off of the Yucatan Peninsula 66 million years ago set in motion the cataclysmic events that led to the extinction of the dinosaurs. But occasionally you'll find, a bone here that's broken or has bite marks on it, and that can help you hypothesize as to how a specific dinosaur died.
That question also kind of gets to some of the research that's happening here in Raleigh in the dueling dinosaurs experience that's happening with that Tyrannosaur and that Triceratops. So between when you say find, I don't know, a baby Triceratops in the ground there, how did that die? And then you get them back in here. How do you begin to understand the lives and deaths of these individual animals?
Yeah, so we try to pull together all pieces of information that we can. So we're collecting data about the rocks that surrounded the fossils, and then once back in the lab, we collect data about the fossils there. And so one of the things that we can do is a technique called histology, where we can actually look inside of a dinosaur bone and see if there's any pathologies or injuries or disease in that bone, which will help us sort of maybe and try to figure out or hypothesize how these particular dinosaurs died.
Do you know how the dueling dinosaurs died yet?
So if you've gone through that exhibit there, we've posted just 3 different scenarios. Disaster, so they died in a flood, or they were fighting, so the name dueling dinosaurs, they were fighting, or dinner. And so right now, we currently don't know how those 2 dinosaurs died. But those are just 3 hypotheses that we've put out there. And so we're working to try to figure that out, try to piece together everything that we can about the rocks, the site, the dinosaur fossils themselves, to see if we can figure out how they were interacting. But to answer your question, no, we don't know how the dueling dinosaurs died yet.
All right, thank you. What's your question? Okay, so the question from the audience, about how long does it take to excavate a fossil and then get it back into the lab?
Yeah, great question. So that depends on what the fossil is. So if it's a really big fossil, like this palm frond, it's taken us a couple field seasons to get it out. Small things we can sort of carefully wrap up, put in our backpack, and immediately bring back to the museum so we can work on it. So it can take anywhere from one field season to many field seasons that stretch out over 2, 3, or 4 years.
I guess that's job security, right, Eric?
That's right. That's right.
Excellent questions. Great questions from the audience today. So, Eric, I get the sense we're getting close to the end of summer. How much longer will you be out in the field?
Yeah, so what's the day? It's the 9th today. So we got 5 more days out here to get this block flipped over, which hope to have done today. And then we'll wrap up on the 14th and we'll drive back to Billings to drop folks off. And then those who are flying out back to Raleigh. Or we have a student all the way from Germany. So that student will be flying back to Germany. Or there'll be 3 of us who are driving back across the country, bringing all the gear back to the museum.
Wow, cool stuff. All right, another question from the audience for you. Yeah, come on up. Come join me.
Loud, but let me use mic. What is behind your back look like a very, very hard work. What can encourage our kids to be a paleontologist?
What can encourage kids to be a paleontologist? Um, so it is hard work, but just, it's really, really exciting work. We get to make discoveries. We get to see things that haven't been seen for 66 million years out here in these rocks. So that's really exciting. And then, just dinosaurs were amazing creatures. And so I think the draw of dinosaurs can help kids get excited about work like this.
Thanks, Eric. I mean, I think it's even cool and incredible that like that palm frond hadn't seen the light. Well, I guess it still hasn't seen the light of day. It's long gone now. But that thing's been underground for tens of millions of years until you happen upon it and then start digging it up.
That's right. That's right. Just pretty exciting to be able to see something that no human has ever seen, that's been buried for 66 million years, and then we get to carefully expose the whole thing, and then wrap it up in plaster and burlap and bring it back to the museum so people can enjoy.
Awesome stuff. I love that like thrill of discovery that comes with science, and especially so visually with paleontology. All right, we've got another question for you. Hi, what's your name?
Asa. What do dinosaurs eat?
It's a great question. What do dinosaurs eat? So dinosaurs like T-Rex, so that T-Rex ate meat, and we know that from the shape of its teeth. So T-Rex had really huge bone-crushing teeth in its mouth that were probably fairly sharp. And they were serrated like a steak knife, so really good for processing meat. And then dinosaurs like Triceratops and hadrosaurs, duck-billed dinosaurs, they ate plants. So we can look at their teeth and we can see the differences, and they were really good at processing plants. So dinosaurs ate meat or they ate plants.
Excellent questions. Fantastic stuff. Getting into the world of dinosaurs. So, Eric, you're wrapping up in just a few days. You'll be back in town. How soon do we all get to see this cool palm frond that you found?
So once we get it back to the museum, you may have noticed that the SECU Dino Lab is full of huge fossil blocks right now, full of the dueling dinosaurs. So it's going to be quite some time before we can get this palm frond into the lab. And so we can carefully remove the jacket that we put on it and start preparing the fossil. So even though we're bringing it back to the museum, hopefully this year, it's still going to be quite a while before we can work on it.
Okay, but just for me, when do I get to see it?
Well, you work at the museum. Well, you can see the fossil jacket, but we're not going to open it for quite some time.
Oh man, okay, I understand. That's fine. All right. Well, wave at me if anybody's got any last final questions anywhere in the theater. I'll throw one more question that did come in offline for you, Eric. Can you talk about how different dinosaurs are depicted in pop culture and in media as being like very aggressive, or like a T-Rex is always got a big grin, for example? How does your work inform what we know and how we think about dinosaurs?
Yeah, that's a great question. So if we think way back when dinosaurs were first discovered, they were thought of as these slow, lumbering, swamp-dwelling creatures that were all drab in color. And then there's been sort of this dinosaur renaissance, where now they're like brightly colored and like race cars, really fast. And now, artists are throwing feathers on almost every single dinosaur, and giving them all sorts of bobs and whistles. And so, as paleontologists work on all these animals and we make new discoveries, and we're using technologies to look at finer and finer details, and we're getting, things in the fossil record we never thought could be preserved, like fossil skin impressions or actually melanocytes, color cells, and we're actually getting to the color of feathers of some of these things. So our work is really helping to figure out what dinosaurs looked like. And so it's probably some combination of modern birds and crocodiles, the two extant groups related to dinosaurs. So the two modern groups related to dinosaurs. And so using sort of what we see now with birds and crocodiles and what we thought of them before, we kind of can come to, I think, a pretty close understanding of what dinosaurs looked like.
Very cool stuff. Yeah, go ahead. Eric, the question is, can you actually give us a sort of like, what's a day in the life of a paleontologist in the field like?
Yeah, absolutely. So for me in particular, I'm up before the sun. We get up and I get coffee going, usually make breakfast. We sit around, we chat, uh, and then we load up our backpacks with the stuff we need for the day. So out here, by our permits, we're not allowed to use any heavy equipment or anything with wheels. So everything that we bring to the site, we've got to pack in on our backs. And so we've had a few really heavy backpack days. And so we gather all the tools and equipment that we need and materials, bring it down to the site, and then we start, with hand tools so far, just chipping away at the rock, getting this block behind me ready to be flipped. The last couple of days, we've been doing a lot of plastering. So mixing up batches of plaster and dipping burlap strips in there and putting them over this jacket so we can create that hard shell. And then today, later on, we're going to be doing some heavy lifting, some rigging up of this block so we can get it flipped over, and then more work to completely encase this block in more plaster and burlap. Then we usually, cut out of here in between 5 and sometimes 7 p.m. and head back to camp, where we sort of relax a bit, cook dinner. So we basically have a full kitchen, other than an oven. We don't have an oven, but anything that you can make at home, we can cook out here. And then, yeah, by then it's, usually 10 p.m. and we're all exhausted. And so we all retreat to our personal tents for a good night's sleep.
So you're out there, yeah, you're camping, but you're not camping next to your dig sites.
Correct. Yeah. So our hike into this site is pretty short. It's maybe half a mile, which is one of the shorter hikes that we have to do for any of our sites. We have some sites in Utah that we work where the hike is even shorter, but we also have sites that are much longer to get to, several miles, hiking in with big heavy backpacks. But this one's pretty easy as far as hikes into a quarry go.
Cool stuff. All right, I see a couple of hands up, and then we'll wrap it up after that. Let's go over here with your question. How many fossils have you found?
Oh, I don't have an exact number on that, but it's got to be in the thousands by now. And that's pieces of dinosaurs, that's pieces of fish and crocs. So altogether, probably thousands of fossils that I've been able to find.
Thousands. Thousands. Wow, that's really cool. All right, last one. What you got? How sturdy? How sturdy? Or, ooh, yeah, I like that better. That's better. How fragile is a fossil when you find it?
Yeah, so it can be very, very fragile, but it also could be the stuff we find that's been weathered out of the rock for a long time becomes sun bleached and basically hardened. So those fossils are pretty robust. But when you first uncover a fossil, it's very, very fragile. So we have to be very, very careful. And we apply an archival consolidant to it called B72. It's basically a plastic B we dissolve in acetone, and that sort of helps mitigate the fragility of these fossils. But if a fossil is just freshly eroded out of the ground, it's probably pretty fragile. Or if modern roots have gotten down in and started eating away at the bone, then the bone can be quite fragile. But like I said, stuff that's already been weathered out and sitting on the surface for a long time, the sun sort of bakes it and bleaches it, and it becomes pretty robust.
Great questions. Well, Eric, thank you for taking time out of your dinosaur digging there to chat with us today about your work.
Absolutely.
And I think it's time for you to go switch out with the poor people behind you swinging axes.
That's right. That's right.
You could go give them a break now. Go swing an axe for yourself. Thank you so much, Eric. This has been fascinating. Everybody say thanks, Eric. They're all clapping for you.
All right. Very good. Thank you.
Take care. Tell the team we said hi, hello. Thanks for doing such great work. Be safe out there. And we'll see you back here in Raleigh real soon.
Yep. Sounds good. All right.
Thanks, Eric. Bye. And thanks, everybody, for coming out to the museum today or for tuning in online for Dino Dig Live. Make sure you check out naturalsciences.org, the museum's website, for more activities, programs, and events. All kinds of cool stuff happening all the time at our museum. Until then, enjoy the rest of your visit. Enjoy the rest of your day. Bye, everybody.